all the water from falling off, because that would be bad. The other thing that I need to tell you here, because this is pseudoscience, we do a whole lot of video type stuff. I'm not doing a ton of it, but what I have discovered after teaching all semester virtually is that the best way for me to do this is to throw a link into chat. And then you click on, you're muted, so you click on that, it opens another tab or window, you watch that, and then you come back over to the main thing and we continue from there. So that's what I'm going to actually start with right now, is a 2-minute video on flat Earth to give you an idea of what this actually is. And then we're going to come back and talk about kind of why this is interesting or important. So let me find the chat here. All right, so this is like 2 minutes and 16 seconds. I'm gonna wait here for you, and we'll be back in just a minute. So there's the link. Go ahead, and I will mute myself too. All right, so y'all should be pretty much done now. Yes? Okay, cool. That's a brief overview. It doesn't show you everything about flat Earth, but it's kind of enough for right now. And yes, there's the this is a drawing on the slide here. This is a drawing from the New York Journal in 1897. So it's not like this is a new idea or anything like that. And yes, the United Nations flag is pretty much a flat Earth symbol. I'm not sure what to make of that. Conspiracy theories abound, but you know, we'll just leave it at that for the moment. This is just another cool one because, of course, you always wonder what's underneath the flat Earth. If it's flat, is it just like a plain old? Anyway, let's not get too caught up in that. But the reason I bring up the flat Earth is because we need to think about epistemology. When we talk about pseudoscience, we talk a lot about how do we know about the world around us. And normally, if I'm teaching the class, I would do a lot of back and forth with the students to think about how we know about the world, how we understand things. I'm going to simplify it a little bit and just talk to you about it because of the time limit that we have. So if we think about it, you know, a lot of stuff. So epistemology is study of knowledge. How do we know things? And of course, sense experience we all rely on. We all rely on our senses to tell us about the world around us. We can't navigate the world without knowing that there's a table here in front of me, that if I walked out into the street, there might be a car that would run me over. Sense experience is not perfect. We can be wrong. Our senses can be fooled. We can see the wrong. We think we see something, it doesn't really happen. But we can check it. So if I ask somebody about the temperature outside, it's very warm today here in Gambier, almost 80 degrees. I think it was 80 degrees. And if somebody else wanted to dispute that, we could check it. So sense experience is pretty good. We rely on it a lot. Now we also think about, we can't see everything or know everything. So, you know, if I asked somebody, how far is it from the Earth to the moon? Obviously, they have not measured that themselves, but they would say maybe, you know, we could look it up, 240,000 miles, give or take a little bit. And we've got other people that we can turn to and check and double check that. And that is, well, that's out of order. That's what we call authority, because we don't always know everything. This is usually when I also talk to them about the fact that, just as you are, my students are always listening to me and writing down what I say. And why should they do that? I'm just this guy who came to Kenyon and said, hey, I got a degree, hire me. No, of course, you can check that. You can check my credentials, and you can check my background. And there's more to that, but I won't go into that. You can also use logic. As long as your assumptions work, your basic premises work in the beginning, you can use logic to also figure things out. All of these are things that we can kind of check, right? The things that we can look at, we can double check, we can ask somebody else. They're all fairly reliable types of things. On the other side, we've got other sources of knowledge, faith or belief. And this is where I'm going to come back to the flat earth in a minute here, which by its very nature can't really be tested. The idea of faith is that it's something that it's a belief. It's something that you know. And how do you know it? Well, you know it, but because you're certain about it. But there's not something that I can go and test. I could check with somebody else if they share that faith, they share that belief, they might confirm it, but it's not really testable. Revelation is another form of knowledge that we talk about. So in various religions, you get revealed knowledge. And again, where does that come from? We don't know where that comes from. It's not something we can test. It's not something we can check. And then the last one that I would throw, well, okay, fine. I'm not looking at my notes well enough. Intuition, again, you kind of know something, but you can't say why you know it. Not something I can really test. And then finally, we get something like consensus gentium, which means common knowledge or common sense knowledge. And that is rarely correct in the first place. Things like lightning not striking twice in the same place, these kinds of things. And so when I talk about flat earth stuff, what we're dealing with, so here's flat earth over here, and what we've got is two categories here: self-correcting knowledge and then sort of untestable knowledge, knowledge that is there, but it's not self-correcting. I can't check it, right? And so I used to always tell students with flat earth stuff, if I took a flat earther up in space and I said, look out that window and look at the earth and tell me what you see. And as long as that flat earther is possessed of decent eyesight and is not, is sober, they would probably have to say, yeah, okay, fine, it's a sphere. But not if their belief is strong enough. If their belief is strong enough, they might very well, after all, moon landing is a hoax and all these other things, be like, well, what are you doing to it? You're pulling something on me here. There's nothing really there. They might still come away a flat earther because of the strength of that belief. Okay, So this is kind of the basics, kind of the background that's going to come up in a lot of different things. And what we're going to find is when we look at pseudoscience and we see people crossing these lines, crossing between these things, mixing epistemologies, having belief masquerade as basically what we're dealing with over here is science, or having science masquerade as belief. Whenever you do that, ooh, bad things happen. So this is kind of our basic background that we're going to be dealing with. Of course, I have to point out one or two other things for flat Earth, because we just, you know, pseudoscience and pseudoscience, we're doing crazy things. So we always bring up silly things. I've yet to see a flat earther show me this kind of lunar eclipse, which would be the disk coming across. Doesn't work that way. And of course, I have to throw this meme up here. If the Earth was really flat, cats would have knocked everything off by now. I have 2 cats. Yeah, I'm kind of thinking that's kind of it. Okay, now we're going to shift gears. So that is kind of, you know, just file that away. That's all going to come back. And now we're going to go to characteristics of pseudoscience. So this is how you recognize pseudoscience. And first, I'm going to show you these characteristics. Then we're going to talk about aquatic apes. And I want you to be able to look for these characteristics as we go through the aquatic ape hypothesis. All right, characteristics of pseudoscience. Originating outside the ordinary channels of knowledge and expertise. A non-expert is necessary to tell you what is going on. And this is where the idea of authority goes out the window. The authorities actually aren't even trusted in this particular case. Ideological or financial conflicts of interest. They're out. Whoever's trying to tell you something is also going to make a buck off of it, or is trying to push an agenda or something along these lines. This one is constant. This one is everywhere. Bypassing ordinary conventions of legitimization. You're not going to find pseudoscience published in a scientific journal. You're going to get publication through documentary. You're going to get websites galore. Some other way of doing this, self-publishing. Publish your own book, because nobody else would actually publish it. That is a sign that you are dealing with something that may just maybe is not so good. Overinterpretation. Overinterpreting a small effect at the very limits of detection. You see one little thing, oh, this changes everything. This is earth-shattering. This is new. This is nothing we ever would have interpreted. And yet, you'll see these. I'll give you lots of examples of this. Anecdotal, experiential, or hermeneutic data and methods. We're not talking about lots of data here. You tell a story about one particular thing. You see this, and that proves what you're talking about. It doesn't kind of work that way. Complaining of a conspiracy of suppression. Nobody wants me to tell you this. This is secret knowledge. Everybody's trying to suppress this, but I'm going to let you in on a secret. I'm going to tell you what really is going on behind all this. Raising more difficult questions than it answers. When you really get down to it, pseudoscience doesn't answer questions. It makes everything else more complicated and more difficult to understand. So those are the characteristics that I want you to watch for as we go through and we talk about the aquatic ape. Aquatic Ape Theory. This idea that our ancestors were once terrestrial, and then we became aquatic, and we swam around for a couple million years, and then we got tired of that and we came back on the land again. And this is obvious because we're naked bipeds, and the only other things that are naked are things like seals and, well, not all seals, some seals, dolphins, and some other things like that. And this goes back to, this originates with a guy by the name of Alistair Hardy, who I don't think is related to me, but who knows. who was a marine biologist who published a real short thing in New Scientist in 1960, Was Man More Aquatic in the Past? And it made a bit of a splash, but then nobody paid any attention to it except for Elaine Morgan, who I'll get to in just a second. This, by the way, is some of the basics here that we go to. You look at what humans have, you look at all these characteristics, and you look at apes, and there are very few things that we share with the other apes. You look at other savanna dwelling species, which is supposedly where a lot of our evolution occurred. It didn't, but that's okay. And it doesn't work very well there. But then you look at aquatics: loss of body hair, subcutaneous fat, descended larynx, psychic tears. That's when you cry when you're sad. We may or may not get to psychic tears. All of these things supposedly suggest, and actually Hardy brought up a lot of these in 1960, but Elaine Morgan is a journalist who really took up and ran with this in 1972 with a book called Descent of Woman. And then you can see that periodically she published more books. Every 5 to 10 years, published another book about the aquatic ape. The best way for us to kind of explore this is to listen to Elaine Morgan. Now, she died in 2012. She gave a TED Talk in 2009, and that's what I want you to see. We don't have time for the whole TED Talk, which is unfortunate because it's very interesting. She's a very good speaker. Does a good job. And so what we are going to do here, I'm going to put the time index in here first, is I want you to watch this from 6:10 to 13 minutes. Oops, that's not minutes. And the link is here. All right, so I will see you in just under 7 minutes. Go. All right, so hopefully you noticed one or two things in there that might have been on our list. Complaining of a conspiracy of suppression. Nobody's ever looked at this. Nobody has ever really investigated this. Nobody, except perhaps for this journal article from 1997 in the Journal of Human Evolution by John Langdon, Umbrella Hypotheses and the Parsimony of Human Evolution, a critique of the aquatic ape hypothesis. Or I think Langdon finally just got fed up and said, fine, I'll look at this. You know, originating outside the ordinary channels of knowledge and expertise. Well, first of all, we got Elaine Morgan, as I said, journalist. No expertise in human evolution or anything like that. Before that, marine biologist Alistair Hardy. Not marine biology is great, and Alistair Hardy probably knew a lot about marine biology, but not necessarily about human evolution. And then the other people that she cites in there. David Attenborough. I like David Attenborough as much as the next guy. He is a great narrator for documentaries. And he did have an undergraduate degree in biology, but since then, he's mostly gone around still narrating documentaries. He's over 90 now, I think, actually. And notice Sir David Attenborough, as if being given a knighthood in England does anything for your credentials for human evolution. I was going to call and see what Sir Paul McCartney had to say, but wasn't able to get a hold of him. So Langdon actually goes through, and we could keep going down the list there, but I'm going to just talk about a few of these characters. So Langdon goes through, and he goes through all these different things that have been talked about, and he classifies them as either possible primary evidence, possible aquatic adaptation, so something that fits with the possibility of an aquatic hypothesis, parallelisms inadequately explained by the hypothesis, traits consistent, primitive traits that don't have anything that are just common mammalian traits, hypothetical reconstructions, kind of sort of just so stories, that anecdotal kind of evidence. But it's too much fun to look at this next one. And it actually, I was trying to get ahead of myself, but it dumped in there at the wrong time. So I want you to watch 2 minutes of this, which is going to be one of the, so this is the link, and let me put the time index, let me find the time index here. This is about one of the things that is supposedly unique to our water adaptation. So watch this video from 11:20 to 13:20, and then we'll, you know, like I said, we'll come back to that now. So did those babies just freak you out or what? That's why I didn't tell you what was coming, because when that first baby kind of goes, it's like, whoa, what is that? This is crazy. This is a primitive mammalian reflex. It is widely shared in mammals. It is not something unique. Does this work in chimps? I don't know. Nobody, to my knowledge, has dumped infant chimps into a pool to see whether this works or not. I think that would be ethically a little bit problematic. This is an example of some of the ways in which you pick these traits very carefully for what you want to do. Or I love this other one that she actually did talk about in the film there. Humans are so streamlined, we're practically fish. I mean, just look at it. Look at that. If that's not a fish, then it's a human. Actually, going back to Hardy from 1960, from Alistair Hardy, he had a quote in there: "All the curves of the human body have the beauty of a well-designed boat. Man is indeed streamlined." I don't know about you, but I'm feeling pretty boat-like. I'm just saying. Oh gosh, there's so many things we could talk about, so many things. This is one that is not actually in the straight up hypothesis, but I bring it up because when you look on the web, the reason women have long hair, and yes, I know that's not correct. That's cultural and other things, is because those babies can hold on to it and not float away. That's why women have long hair, so the baby can kind of hold and not get washed away. And yeah, it's great stuff. Or maybe, you know, we could turn to sweating, because there's a lot of stuff about sweating that is weird, and we're naked, so that is really strange. Thermoregulation becomes a strange kind of thing. And Elaine Morgan and others are implying that the reason that we do this, when we get that subcutaneous fat layer, is to keep ourselves warm in the water. And humans are really weird. We sweat strangely. So we have all these eccrine sweat glands that have a very diffuse watery sweat, and then evaporation allows us to cool. It's actually probably the most advanced cooling system of any mammal on Earth. And we also have apocrine sweat glands, which are the smelly ones in our armpits and other places. What good does this do in the water? No evaporation in the water. And if you're communicating by smell with apocrine sweat glands, that water kind of dampens the movement of molecules across like this. So smelling kind of falls out of the way. So that's a little bit weird. Of course, you know, this is from an actual journal called Medical Hypotheses back in 1985. Anyway, in water, only the head needs to be protected, because why do we have hair on our head? Well, because, you know, otherwise we're swimming and we'll be fine, except we need that up top there. And one could say, you know, that just like aquatic animals, our nostrils are up on, oh, wait a minute. No, they're not. They did not migrate up to the top of the head. Oh, sorry about that. So many different things. David Attenborough's big one is bipedalism, which the only time you see other apes walking bipedally on a habitual basis is when they wade. Yep, it's true. They do that, but that doesn't mean that that's the explanation for bipedalism. Talk about breath control. We have breath control because we're bipeds. If you're a quadruped, your breathing is tied into your gait because of the way the anatomy works and the way the arms and legs are moving. This is why herbivores and things like wildebeest can't run forever, or horses can't run forever, because they get overheated, because they can't cool down, because it's all tied in and the heart rate goes up and they have to breathe. And we don't, because we walk on two legs, which is also really weird. But so the last thing I'll bring up is just that Langdon, one of the other things that Langdon says here, remember that the title of the article had to do with umbrella hypotheses. So an umbrella hypothesis is something that explains everything. They're very hard to disprove because they explain so many different things, supposedly. And there have been others that have been proposed about human evolution before. Hunting, man the hunter, was a big umbrella hypothesis. Because we hunted, we got the meat, which made the brain bigger, which allowed the brain to get bigger, et cetera, et cetera, et cetera. Male provisioning, Owen Lovejoy, 1981. Because males would bring food back to the females, he actually sort of reinforced gender roles, stereotypical gender and sex roles in evolution, which is something that happens a lot in pseudoscience. Why do I address this? Why do I talk about this? Well, I'll actually tell you why I talk about it, why I first started talking about it, which was well before we got to pseudoscience. I'm going to jump a couple slides here. I had a student named Misha Pino, and Misha would come into my human evolution class every day and say, when are we going to talk about aquatic ape? When are we going to talk about aquatic ape? When are we going to talk about aquatic ape? And I kept saying, no, no. And then I finally said, okay, Misha, I'm not going to talk about aquatic ape. I'm going to talk about the aerial ape. All right. Because humans and birds are very similar. We're both bipedal. We have strong hind limbs for jumping, male, female provisioning of the young, right? Elaborate displays for mating, just like bowerbirds. Humans do the same kind of thing. And primates are closely related to bats. Don't ask me what that means, but it works. So why not just say aerial apes as well? Raises more difficult questions than it answers. If we're back to our criteria of pseudoscience, complaining, a conspiracy of suppression, which I call nobody likes me, everybody hates me, I think I'll go eat worms. You had to be there, anecdotal, experiential evidence that we've seen over interpretation, stuff like the water babies, over interpretation. Oh, well, look, you dump them in water and they don't die. Briefly, they don't die. Leave them there very long and they might have a problem here. So all these things, unusual source, financial conflicts of interest, bypassing ordinary channels, overinterpretation, all 7 boxes are ticked. This is pseudoscience. We don't need to take this seriously. But it's going to be portrayed as you're shutting it down. You're the big, the academics are afraid to engage this. They got something to hide. And the larger issues with this is public views of science. And when you start crying conspiracy and you think aquatic ape, no big deal. But you start seeing where this, a little chink, a little bit of doubt, and probably get a little doubt involved. And then people will question more stuff than this. So the aquatic ape in itself is not evil, but there are consequences to stuff like this and entertaining them in a serious fashion. That's my quick version of the aquatic ape. Oh, and I should show you my shirt here from NASA, not flat, we checked, which I wore specifically for this lecture. All right, I'm over by about 30 seconds. So I'm going to stop there and let Kim jump back in if she wants to, and I guess entertain some questions if you have them.
Yeah, I didn't see any folks put any questions in the chat up to this point, so feel free to either put your question in the chat or just unmute yourself and ask
They're behaving
away.
very well, just like my students who I yell at all the time because I'm teaching all virtually this semester. I'm always yelling at them, unmute yourself. I'm just sitting here talking to my office. So yes, please feel free to unmute and ask a question.
I have a question. Hi, I'm Lindy, she, her.
Hi, Lindy.
Hi, yeah, Bruce recognizes me because I was an AND student and a 2019 graduate. And I'm wondering, this is like a very large question, so I'll try to word it like as best, or I guess it's a broad one. I'll try to word it as best as possible. But why do you think that pseudoscience has become such I won't say important, but such a defining part of like the alt-right and modern conservatism? Like, like white supremacy and misogyny are definitely reasons. And but I'm wondering if there's, anything. Oh, sorry, that's my work group chat. Anyway, I'm wondering what your thoughts are, because I feel like pseudoscience has come in from like this little tiny fringe and become like mainstream.
It was never as fringe as you think it was, and you're
Okay.
exactly right. And all I can say is stay tuned for part 3 and 4, where we will get into exactly some of that. What I'm about to do in class tomorrow is going down an incredibly dark road of pseudoscience that leads into racism and right-wing conspiracies and very, very bad things. Part of it is anti-intellectualism, a long history of anti-intellectualism. We trace this all the way back, you can trace it back a really long way. Distrust of those who have knowledge. And we also, we query a lot in this class. We query science as well. So it's not just all about the pseudoscience, it's also about what is science and what can science say. But yeah, this is actually one of the most depressing classes that I teach, because of that, of exactly what you bring up, is that we end up in such dark places, and it just gets reinforced. And the pseudoscience is easy. It's easy to believe. It's easy because it's much easier to cast doubt on something else and just say, hey, I'm just asking questions here. I'm just trying to point out the alternatives. But those alternatives then reinforce these stereotypes and these things that we have, and actually, yes, make it much, much worse. And the internet is part of it. The internet, since the internet has really come along within, it was a lot, there was still plenty of pseudoscience. It just didn't spread quite as fast because you had to put magazine articles and other things out. We'll talk a little bit about that next time with Bigfoot, which is the least depressing of the pseudoscience that we teach.
Thank you, Bruce.
In the chat, Lynn Schaefer asked, how did Elaine get a TED Talk?
You know, the TED, pretty much anybody can get a TED Talk these days. I think it's been for a long time. You know, the idea has not gone away. There's enough, it's an easy enough story to tell. And I think also because you're doing that, because you're just, I'm just offering an alternative here. And people are like, well, yeah, why aren't you talking about that? So because you play the conspiracy card, nobody will listen to me. And then people are like, well, wait a minute, how come nobody really takes this seriously? And then they go and they do it. And if you listen to this talk, if you found this talk online and just listen to it, you'd probably, and you didn't know anything about human evolution or anything else, you'd probably go like, wow, I wonder why nobody's talking about that. That's really interesting, because she tells a good story. But you do need to listen, because a good story is not all that there is to it. And I'm not going to mention what happened in the chat just there, because I'm not really a big fan of puns. Ask my daughter, or ask Jess. I see Jess on there. I think she used to get some puns going in class.
Hi, Bruce. I also have a question.
Okay.
I'm also a 2019 graduate, so hi to all the other Kenyon alums out there. So you mentioned this one student who had like so much beef and really wanted to know about aquatic apes, like was really pounding it in. I want to know, do you have another like student, or has it become more prevalent recently? Like, do you have more students who are like ready to believe these conspiracies? Like, or do you have memories of
aquatic ape stuff? No, because I actually now teach it in other classes. But particularly after this, I also bring it up in the bioarchaeology of Africa class. I just address it, but I partially address it to show other students who aren't taking the pseudoscience class about pseudoscience, because I think that's been enough. That's been I've discovered how important and how widespread it is, that I kind of wish I was teaching pseudoscience every semester, except that give me another week or two and I'll be like, no, I don't want to teach this again. I'm going to want to go wash my brain somewhere. Coming into the pseudoscience class, we hit them from the get-go. So I do get some that are kind of like, well, yeah, but come on. But usually we've done enough with kind of showing them the problems that they're like, oh, yeah, I kind of get it. I would say, you know, but that's a self-selected group. I would say outside of Kenyan students that I am dealing with directly, yeah, you got lots of people that are going to be doing. I mean, look at QAnon. QAnon wasn't even a thing. Well, one of the last times we taught this, and then last semester we also taught it last semester. I was going to do QAnon stuff, and everything sort of blew up. And now it's sort of gone, but not gone. It's like, whoa, wait a minute. Some things I don't look into. I try not to look into because I know what's beneath them. It's bad. Somebody had a question here about, you know, anti-vaxxers. I will talk about that. The short answer to the anti-vaxxer stuff, how do you talk to people who are anti-vaxxers or who don't believe they should get a COVID shot, who think this is all a conspiracy? The best advice that I can give is to make it personal. You know, make it relatable to something, to if there's a individual that you know who unfortunately has died because of COVID or been very sick and hospitalized because of COVID, you try to bring out real stories like that. If it really does cross over into a belief system, convincing is, like I said with the flat earth stuff, convincing really doesn't work. You can show them as much evidence to the contrary as you want to, and if that really is a firm belief that they have, they're going to have to somehow find a way around it, or they're not. Unfortunately, is what we've learned by doing this. And we were talking about anti-vaxxers for years before we got into this bit, because yeah, but anti-vaxxers is like part 4 after UFOs and other things like that. I don't know what else we got over here. Anybody wants to chime in with a verbal? Yeah, go ahead.
I remember watching that TED Talk several years ago. I don't remember who or why I was alerted to it, but I remember watching it. I was a biology major at Kenyon and taught biology for many years. And I was intrigued with the talk. And she talked a bit about finding some fossil evidence in Florida about,
Right.
what was it, rhinoceros?
Rhinos, yeah.
But she never talked about any fossil evidence about aquatic humans.
Right, yeah, which is, again, that selective nature of what is being presented and what is not. You can actually, if you dig further into it, there's a couple other people. It's actually been a bit of a resurgence in paleoanthropology of a modified version of the aquatic ape in the last 10 years or so. And it's really more, it's often referred to as maybe the waterside ape. And certainly from an ecological standpoint, if you're living near a coastline, you are accessing a whole range of ecological zones there. And it's a pretty cool place because you do have resources coming from the ocean. You've got land, you've got near shore, you got on shore, you got away from shore. So it's all pretty good. The one thing that people have pointed to try to give you a fossil piece of evidence from humans is Homo erectus. And what's called pachyosteosclerosis, which is the big brow ridges that Homo erectus has, the really developed brow ridges, and then some of the paranasal sinuses and stuff like that, which they equate to basically things like manatees, where the skull is relatively buoyant, but it doesn't actually work with Homo erectus because the paranasal sinuses don't actually help, and the bone and the thickness of the skull in Homo erectus is actually very, very thick. But that is the only thing that you point to, because everything else is a terrestrial adaptation. She does point to our supposed web digits, which no other primate is supposed to have, and we don't really have, but we kind of do. That's another primitive retention. And actually you can look at proboscis monkeys who have very webbed digits, but that's also you go back to embryos and you get webbed digits. And so that's another one. But yeah, you're right. It's she talks about rhinos and rhino fossils because it fits. Because now I can show you that even the rhino had an aquatic ancestor, but she includes these things that wallow in the mud and not like hang out in the water all the time. I mean, even hippos, if you look at hippos spend a lot of time, they forage on land, and so it falls apart very easily if you just start picking up rocks and looking underneath them. It's like, yeah, this doesn't hold water. Any other burning questions? What have we got over here? Yeah, you can't convince people who won't listen to logic. Yeah, though this is true. This is one of the things we found a lot.
Bruce, this is Kevin McDonald. I'm not in the class of 2019.
Well, that's good because those people, I'm like, you haven't even been gone. Go ahead.
I started the year after Norm graduated, so. It seems to me that what an interesting aspect, and maybe this is in chapter 2 or 3 or 4 for you, is that looking at the history of science, there have been a lot of people that were laughed at and a lot of people that were amateurs and proved to be spectacularly correct. The history, not only science, but math and other things. And I wonder if you are at any point going to give us as an example of somebody who met at least some of the principal definitions of the pseudoscience and turned out to be science.
Yes, indeed. It's something that I'll talk about with the Bigfoot stuff, because you very much get one of the terms that is used by one historian of science is the crackpots versus the eggheads, the sort of amateur naturalists who know a lot about the world around them versus the egghead academic scientist who doesn't know anything about the real world. And you're exactly right, which is why I said that we query both science and pseudoscience in this. And science is very good at trying to shut down what is not mainstream, what is not the main thing. Plate tectonics and continental drift and various other things like that were once seen as way far, not to mention relativity as being this lunatic fringe, if you want to use Elaine Morgan's terms, out there with the UFOs and the Yetis. And so, yeah, we definitely do want to bring that up, because the other big thing that we're dealing with here is science as cultural authority. So if you're a scientist, then what and sometimes if you just look like one, if you put a lab coat on, then some people are going to go, well, I trust this guy because he says it. And then you don't necessarily know that person actually does. So yeah, your point is very well taken. And I will be, at least with Bigfoot and maybe some of the others, it definitely comes up. We definitely talk about that aspect. And it's one of the reasons why, in some ways you do need to engage with things like Aquatic Ape,
Right.
I'm not going to ever say, was there in that modified form that I was just mentioning, that water side kind of stuff, water being we're obviously dependent on water. Water is a very cool and useful thing. It may have had something to do with it. It certainly doesn't have anything to do with a huge aquatic phase that we had, at least from nothing that we can see right now. But then again, human evolution is weird.
Mm-hmm.
We find, Homo naledi was discovered a few years ago, dated 250, 350,000 years ago in South Africa, and it doesn't look like anything we expected. So in some ways, I'm never going to say no with human evolution, because we found too much weird stuff, Floresiensis with little tiny people in Flores and in Indonesia. Yeah, that kind of thing.
Yeah. Thank you.
Yep. There's lots of things, other questions here about what are your opinions on pseudoscience like traditional Chinese medicine. I would really prefer to have my colleague Dave Suggs, who I often teach this course with. We developed it together. He's a cultural anthropologist and has done a lot with ethnomedicine. I'm not going to dismiss traditional remedies in various places out of hand. Often they don't work and are very much pseudoscience. Western biomedicine, also, we don't understand everything that is going on there either. There's a lot of stuff that's done in Western biomedicine, like, hey, we did that and it worked, but we don't really know why it worked. And sometimes it doesn't work either. Belief plays a role, you know, placebo effects and all those kind of things. So that's a more complicated thing. We don't do a lot of that except for talking about vaccines and the problems of anti-vaxxers and stuff like that in this class. We try to keep this as lighthearted as we can. I mean, that's why we bill it as we're going to do ancient aliens and we're going to do Bigfoot and we're going to do UFOs, which we do. It just turns out that what's behind most of that stuff is sexism and racism and misogyny and all the other things that were brought up earlier. And it's not harmless. So if you really are one of these folks that loves watching ancient aliens, please don't. I'll get there. They're funny. Giorgio Tsoukalos is hilarious, but he has other bad consequences. How do you write certain beliefs within religious affiliations with pseudoscience? We do a big section on which I'm not going to do in this series, on creation and evolution. We do a lot with the Creation Museum and the Ark Encounter and that kind of thing. And we really get into, what you really get into there is both a financial conflict of interest and an ideological conflict of interest. They're out to make money and they're out to convert people to be what you want them to be, which happens to be stereotypical gender and sex roles, with male patriarchy and everything else. And so we talk a lot about, you know, religion and faith and belief have a certain role. Science has another role. It's when those two cross, when they start to pretend to be the other, that you get into problems. So that's the short version.
That sounds like an excellent note on which to end this week. So thank you everyone for joining us, and thank you so much to Bruce. We hope to see you in the weeks to come.
Bigfoot coming up, Sasquatch, telling you, it's great stuff. Bonus points, I offer this always to the students, bonus points for anybody who finds Bigfoot. Nobody's done it yet. Come on, get out there. I need more eyes. Go, I want to find Bigfoot.
Thank you.